What is a data warehouse? So, as we all know, it's defined in different ways, but we can say that it is data warehousing provides architectures and tools for business executives wherein they can organize, understand, and use their data to make some decisions, okay, some strategic decisions. As you all know, data warehouse systems are valuable tools in today's competitive, fast evolving world, and we all know that many firms have spent millions of dollars in building these enterprise-wide data warehouse. So then what is exactly a data warehouse? So data warehouse, it's difficult to frame a definition for it, but we can say that data warehouse refers to a data repository that is maintained separately from an organization's operational database. Okay, it's a decision support database that is maintained separately from organization's operational database. And data warehouse will allow for integration of variety of application systems. That is, we can integrate a variety of application systems, and they also support information processing by providing a solid platform wherein we can just consolidate the historic and data for the means of analyzing. So it is it supports information processing. By how does it supports? By providing a solid platform of consolidated historical data for analysis. So according to different leading architect, who is William H. Inmon, so it is a data warehouse. How does he define data warehouse? He has defined it as a data warehouse is subject oriented, integrated, time variant, and non-volatile collection of data in support of management's decision making process. So, so it presents the major feature of data warehouse. These keywords, whatever it's there, like subject oriented, these subject oriented, integrated, time variant, and non-volatile. These are the four keywords that will distinguish the data warehouse from other data repository like RDBMS, transaction processing system, file system, and etc. Okay, so let's move on and these. Oh, so let's have a closer look at these key features. Subject oriented. So what is subject oriented? A data warehouse. It's organized usually around major subjects such as customer, product, sales, supplier, and it focuses on modeling and analysis of data for decision makers, not on daily operations or transaction processing. So it concentrates on day-to-day operations and transaction processing of an organization, and the data warehouse usually focus on modeling and analysis of data for decision makers. So we can say that data warehouse, it provides a simple and concise view of particular subject issues by excluding the data that are not useful in the decision support system. So it concentrates on day-to-day operation and transaction processing of an organization, and it's also organized around major subjects such as customer, product, and sales. How about data warehouse being integrated? So data warehouse is usually constructed by integrating multiple heterogeneous sources such as RDBMS, see, relational database, flat files, and online transaction records. Data cleaning and data integration techniques are applied on these data in order to ensure consistency in naming convention, encoding structures, attribute measures, etc. among and so on among different data sources. An example could be hotel price, currency, tax, breakfast covered, etc. When you move the data to the warehouse, it is converted. So time variant. Here data is usually stored to provide information from historic perspective like past to 5 to 10 years. So data warehouse data, it provides information from historical perspective, like for example for 5 to 10 years. And every key structure in this data warehouse contains either explicitly or implicitly a time element. So every key structure in this data warehouse in this time variant will contain an element of time either explicitly or implicitly. But the key of operational data may or may not contain the time element here. So time horizon for the data warehouse is significantly longer than of operational systems. Non-volatile as well. Data warehouse is always a physically separate store of data which is transformed from application data found in operational environment. So due to the separation, a data warehouse does not require transaction processing, recovery and concurrency control mechanisms. The only two operations which are required in accessing this data are initial loading of data and access of data. So these are the four key features of data warehouse. It is subject oriented, it is time variant, non-volatile and also integrated. So how do we distinguish between these data features of OLTP and OLAP? So what is this? What are the distinguishing features of this OLTP and OLAP? An OLTP system is customer oriented online transaction processing. OLTP is online transaction processing. It's customer oriented and it's usually used for transaction and query processing by clerks, clients and information technology professionals. Whereas an OLAP, that is online analytical processing system, is market oriented and it is used for data analysis by knowledge workers including managers, executives and analysts. But this is with respect to users and system orientation. So OLTP is customer oriented whereas OLAP is market oriented. When we have to distinguish based on these data contents, an OLTP manages current data that typically will be detailed to be used for decision making, whereas an OLAP system will manage large amounts of historic data and it provides facilities for summarization and aggregation, and it also stores and manages information at different levels of granularity, and these features will only help us to will make the data easier to use for informed decision making. So with respect to data contents, OLTP manages current data whereas OLAP will manage the historic data. Database design. An OLTP usually adopts an data model, that is entity relationship data model, and an application oriented database design. And OLAP on the other hand, it adopts either a star or a snowflake model and a subject oriented database design. So these different types of models which are used in OLAP we'll be discussing next. So an OLAP system typically adopts either a star or a snowflake model and a subject oriented database design. So when it comes to view, an OLTP focuses mainly on current data within an enterprise or department, and it doesn't refer to any historic data or data in different organizations. Whereas OLAP is in contrast with this, where it spans multiple versions of the database schema due to evolutionary process of an organization. So OLAP usually deals with information that originates from different organizations and it tries to integrate that from many data store because of this huge volume, OLAP data will usually be stored on multiple storage media. So the amount of data which is in case of OLAP is more when compared to OLTP, and OLTP mainly focuses on current data whereas OLAP will span multiple versions of database schema. Access patterns. The access pattern of an OLTP consists of we'll usually have short atomic transactions such as system requires concurrency control and recovery mechanisms, and as it concentrates mainly on short and atomic transactions, that particular system requires concurrency control and recovery mechanisms, whereas access to OLAP will usually have only read-only operations, so there will be no modifications even though there could be complex queries. So access to OLAP are mostly read-only operations, whereas here the system contains short and atomic transactions. Hence, we need to maintain Whereas the system requires concurrency control and recovery mechanisms. So this is how it is being distinguished in the form of a table. So this is comparison of OLTP and OLAP. So whatever we have. So next, how are organization using the information from data warehouse, where all they are using? So many of the organization will use this information to support business decision making activities, including increasing customer focus, wherein they just try to see the customer pattern, customer buying pattern, like what's the time, what's the budget cycle, budget, buying preference, appetites for spending, all those, and repositioning the products and managing the product portfolios. Like usually they will analyze what are, if a particular person buys one product, maybe he'll tend to buy one more if they are arranged in sequence. So repositioning products and managing portfolios. How do they do this? By comparing the performance of sales. Usually they'll be compared in quarter or by year or by geographic regions in order to fine tune production strategies. And they also analyze operations and look for where they look for source of profit, and they also try to manage customer relationship, making environmental corrections and managing the cost of corporate assets. So how organizations are using this data information from data warehouse, that is in this way: to increase customer focus, to reposition the product, to get more profit, to analyze the operation, to manage customer relationship. For all these things, we are just using this information from data warehouse. So because operational database usually will store huge amounts of data, we may wonder like why are we not performing an online analytical processing directly on such databases, and why are we spending more additional time and resource to construct a separate data warehouse? That could be one of the questions which will flash into our mind, like why not we perform the same analytical processing on directly the databases? Why we have to just spend additional time and resources to construct a separate data warehouse? So these are the reasons why we need a separate data warehouse. So high performance for both the systems. Why do we need a separate data warehouse? This, as you all know, these operational databases are store huge amount of data. So high performance for both systems. If DBMS, it's tuned for OLTP, access methods, there will be indexing, concurrency control, recovery, whereas warehouse is tuned for OLAP, where it processes complex OLAP queries, multidimensional view consolidation. So this high performance for both the systems, like the DBMS alone cannot have high processing, which is required for both the systems, and different functions and different data. Missing data, when it comes to missing data, decision support requires historical data which operational DBs do not typically maintain. So that's the reason why we are maintaining a separate data warehouse. The reason is that decision support, that is your data warehouse requires historical data, whereas OLTP usually works on current data. So what happens, if you DBs, as they will not maintain this historical data, it's obvious that we should have a separate data warehouse. Data consolidation, this DS data warehousing requires consolidation of data from heterogeneous sources. Data quality, different sources typically use inconsistent data representation, codes and format which have to be reconciled. So there are more and more systems which perform OLAP analysis directly on relational databases, but it's just an overhead for the database. Okay, so what happens if when these concurrency and recovery mechanisms, if they are applied for OLAP operation, it may create confusion in the execution of concurrent transaction and reduce the throughput of the OLTP system. Hence, we have to just separate operational database from data warehouse, because both have different structure, contents and use of the data in the system, in these two systems are different. isn't it? So as each one is performing operations, different operations on different set of data. So if we try to perform all the operations on OLTP, it may support, or OLTP, it may not support. Some operations may not be supported by OLAP. So it's very much required to have a separate data warehouse depending on the requirement. So when it comes to data warehouse architecture, we have this multi-tiered architecture. And this is the multi-tiered architecture. It's a three-tier architecture wherein the bottom tier, we have this bottom tier which is an warehouse database server. So this is the bottom tier. We have a data warehouse server. It is almost a relational database. This is RDBMS. Backend tools and utilities, whatever we have, this backend tools and utilities. These are used to feed data into the bottom tier from operational or database and other external sources like customer profile information provided by external consultants, like that. These tools and utilities perform data extraction, cleaning and transformation, and they also load and refresh. See, they extract, they clean, they transform, they load and refresh functions to update the data warehouse. To update this data warehouse, these tools and utilities will perform extraction, cleaning, transformation, loading and refreshing. So the data are extracted using this application program interface known as this gateways. Using gateways, they will usually, the data is extracted. And this gateway is supported by underlying DBMS. And it allows client programs to generate SQL code to be executed at a server. Like an example of this could be an ODBC. The gateway of example could be Open Database Connection ODBC or OLEDB, that is Object Linking and Embedding Database, JDBC, like that. So this tier will have a metadata repository as well. If you can see here, it also has a metadata repository. This will store information about the data warehouse and its contents. And this metadata repository is further, we will look into this further. So at bottom there we have these things. Okay, so bottom tier is a data warehouse server that is almost always a relational database. So backend tools and utilities are used to feed data into this bottom tier from operational database or external sources. And we have tools and utilities to perform extraction, cleaning, transformation. And when it comes to middle tier, we have OLAP server. OLAP server that is typically implemented using either the relational DBMS model or a multidimensional OLAP. So this, in the middle level we have this OLAP server, and they can be implemented either by using relational OLAP model or multidimensional OLAP model. And these OLAP servers we will discuss in detail next. And at the top tier we have the front-end client layer, which contains query and reporting tools. We have query and reporting tools here, analysis tools and data mining tools at the top end. So this is the three-tier data warehousing architecture. So middle tier we have relational OLAP and multidimensional OLAP that implements multidimensional data and operations. And top tier, as we have seen, we have front-end client layer, which contains query and reporting tools, analysis tools and data mining tools. So those are the that is the architecture of your data warehouse. So when it comes to the models of the data warehouse, we have different models. The different types of models are enterprise warehouse, data mart, virtual warehouse, and virtual warehouse. So these three data warehouse models we have. Enterprise. What does this enterprise warehouse do? This enterprise warehouse collects all of the information about the subject spanning the entire organization. So it contains information about entire organization. And an enterprise, it usually collects information about subjects spanning the entire organization, and it provides corporate-wide data integration, usually from one operational systems or external information providers, and is cross-functional as well. And usually it contains detailed data as well as summarized data. So this enterprise warehouse will be implemented on traditional mainframes, computer servers, super servers, parallel architecture platforms. The enterprise data warehouse is used in it's implemented usually on traditional mainframes, computers, super servers, parallel architecture platforms. And this model, this enterprise warehouse model, it requires extensive business modeling, and it takes years to design and build. Okay, so we have data mart. A data mart contains a subset of this corporate-wide data that is of value to a specific group of users. So everyone will not be using this, only a specific set of users will be using this. And the scope of this is it's confined to specific set groups such as marketing data mart. However, it also involves complex integration in the long run if design and planning were not enterprise-wide. So we have these independent marts as well. So these are sourced from data captured from one or more operational systems or external information providers, or from data generated locally within a particular department or geographic area. So dependent data are sourced directly from enterprise data warehouse, whereas independent data are sourced from data captured from one or more operational systems or external information providers. Next, we have this virtual warehouse. A virtual warehouse, here we have a set of views over operational databases. And for efficient query processing, only some of the possible summary views we may need it. And virtual data warehouse is easy to build, but it requires excess capacity on operational database servers. So what are the pros and cons of top-down and bottom-up approach to data warehouse development? Is there any pros and cons? Yes. The top-down development of an enterprise warehouse, it serves as a systematic solution, and it usually minimizes the integration problems. But it is expensive and it takes a long time to develop, and also flexibility is lacking here because it's difficult to achieve consistency and consensus for a common data model for the entire organization. So top-down development of an enterprise warehouse, it's expensive and takes a lot of time. On the other hand, the bottom-up approach to the design, development, and deployment of independent data marts provides flexibility, and it's low cost, and it has rapid return of investment. But it can lead to problems when we try to integrate various disparate data marts into consistent enterprise data warehouse. So bottom up, what happens? To the design, development, and deployment of independent data marts, it provides flexibility, low cost, and rapid return of investment. But it can lead to problems when we try to integrate various separate data marts. So depending on the source of data, data marts usually, as we discussed earlier, they can be independent or dependent. So independent are sourced from data captured from one or more operational systems or external information providers, whereas dependent are directly, they take the data or source directly from enterprise data warehouse. These are the different models of data warehouse: enterprise, a data mart, and virtual warehouse, and what are the pros and cons of this top-down and bottom-up approach. So the data warehouse, if we will try to look into the backend tools and utilities which are used, they include the following functions. As we have seen in the architecture, we have tools and utilities, isn't it? So these are the following functions of those utilities and tools, like data extraction to get data from multiple heterogeneous and external sources, cleaning the data wherein they try to detect the error in the data and rectify them when possible, and data transformation, they convert data from legacy or host format to data warehouse format, load, Usually what it does, it sorts, summarizes, consolidates, it views, checks integrity, and it builds indices and partitions. These are some of the functions of tools and utilities. And refresh, what it does, it propagates update from data sources to the warehouse. So besides this cleaning, loading, refreshing, and metadata definition tool, this data warehouse also has a good set of data warehouse management tools. So it also has some warehouse management tools. So that we will not discuss here. Okay. So what is the metadata repository in the architecture then? So this metadata, it's nothing but information about the data. Its metadata is data about the data. So when it is used in a data warehouse, this metadata are the data that define these warehouse objects. Metadata is the data defining the warehouse object. It stores what are the things a metadata repository should contain. It should contain description of the structure of the data warehouse. What is this description? That is, it should have the schema, view, dimension, hierarchies, derived data definition, data mart locations, and contents. So metadata repository should have this description of the data warehouse. Then operational metadata. This is history of this migrated data and transformation path, concurrency of data, monitoring this information. Operational metadata. It should have a data lineage, monitoring information. And it should also, this metadata should also have algorithms for summarization. So, like which includes measure and dimension definition algorithm, data on granularity, partition, subject areas, aggregation, summarization, predefined queries, and reports. And mapping from operational environment to data warehouse. Here, source database and their contents, gateway description, data partition, data extraction, cleaning, transformation, and defaults, data refresh and purging rules and security. All these should be mapped. So user authorization and access control is required here. And data related to system performance includes indices and profiles that improve the data access and retrieval performance in addition to rules for the timing and scheduling of refresh, update, and replication cycle. So business data, it also includes business data wherein it has terms and definition, ownership of information, charging policies. So these are the different information which is maintained in the